Data structures and algorithm, experiment number 2. So here we're gonna see the application of stack, but like by evaluating a postfix expression. So here's the code. So from top to bottom, I'll just explain you the code. So first thing, we'll come to this part later. So before that, a postfix expression is something which will look like this. So 10 2 8 star, then a plus 3 minus, will look like this. So here, so this part of the code is my own custom code to show that uh, this code was written by me. So the actual implementation starts from here. So the first thing, we're, we're gonna we're gonna get an input from the user, this input, and we're gonna store that in a string. We use the getLine function to like take the entire input in a line. So here we declare a stack called calc block. And here we have one more string with all the operators that we're going to use. As plus, subtraction, multiplication, division, and modulus operator. Then we use this. Then we use this uh, string stream. It is actually a class. Is an it is actually an inbuilt class, and like and I'm just making an object called tokenizer container, and I'm passing the input to this. Why I'm doing this is, so say this entire thing is a string. So I want this to be I want this to be separated by spaces. The first input is 10, then there's a space. So in order to achieve this, like here, every time when I use this while loop, automatically this uh, the entire string will be divided into 10 to 8 star. Here is the delimiter, it's a space, and this object passes its value to I. So I'll come to this later. In C, there is this function called string tokenizer. This literally does the same thing, but its implementations are different. We are using the inbuilt string stream to achieve this. The same thing only, but that only will work for casta pointer. But here we could just directly pass the input string and get the output. So in order to get these individual 10 to 8 star without the space, I'm using this class with this object. I'm passing the input to this object. The constructor will take the rest of the things that need to be done. And here I'm just declaring a string I to store like the value each time and we go through it. Here I'm using the getLine function, and I'm getting the input from the string stream, uh, and that input is being stored at I, and the delimiter is this thing, space. So every time when this while loop runs, this string is broken into like in parts of space. First, when the while loop runs, uh, it goes till 10. When it sees a space, it breaks and passes the 10. That 10 is being stored in I. Then it then when the loop runs again, it goes to 2. After it sees a space, it breaks there, and then it passes the value to I again. Like this, the same thing will be going again and again. So here I would get each and individual value, say 10 or an operator, everything will be divided based on the delimiter given, which is a space. Then here, if this value is not in the operators list, that is, if it is not in this operators thingy, then that means it is a number. We need to directly push it to the stack. So here, if this fails, then it is directly pushed to the stack. To convert a string to an integer, I'm using the story function. It is an inbuilt function in the okay is an inbuilt function in the string header file. As I'm using uh, as I'm using like as I'm using this header file, this will include all those header files needed. Like this is actually the STL header file. So then okay, so this toy function comes under the string header file, which is included in this header file. So automatically I can access this, I can use a story function, and I'm passing this value I. This I will be converted into an integer. So this integer is passed the stack. So the stack is stored like this. So it is uh, first in, last out. So it gets stored. So first 10 goes, like it's not an operator, it gets stored. Then 2 goes, it's not an operator, it gets stored. Then 8 goes, it's not an operator, it gets stored. Then when multiplication, the star goes, what happens is, it is inside this operator thing which we gave, string, operator string. So what happens is, this returns uh, like it returns a position inside the given string. So this becomes true. What happens is, the topmost uh, the top part of the stack is stored as the second operand. So initially we pushed 10, 2 and 8. So 8 is being called here with the top function and stored in a variable called second operand. Then 8 is popped. Then again the top function is called. Now like the value 2 will be in the top, so 2 will come here, and that value will be stored in first operand. Then 2 is popped. Then after that, what we do is we push this. Okay, after that we call a function called calculator, passing first operand. This is the second operand and the operator I that we found. So calculator function goes here. Calculator is basically a switch case like function, like calculator is the main function. Inside it, it, ha- it has a it has a it has a switch case statement that based on the operator operations will be done, and and the and the and the result will be returned. So if you see here, F is the first operand, S is the second operand, and last one is the operator I. So here I've used const. Uh, it is a good practice to use const when the value isn't changed. So I just use const, so that implicating that I'm not going to change the value. As I'm getting the address, the actual location of the variable. Like if I don't give this ampersand, it will be copied. Like the whatever value I pass, it'll make one more copy and do. But as I'm giving the ampersand, it goes to the actual memory address instead of copying. So I'm using const as a good practice to show that I'm not gonna uh, modify this value. So here in the switch case statement, as this is a string, I'm just accessing the first value. That is going to be the operator. So I just say I of 0. So what this does is this returns a character. Uh, yeah, this returns a character point. Okay. Yeah, this returns a character variable or character pointer that is in turn checked here. If the character is equal to plus, then this operation happens, first plus s. If it is minus, first minus s. If it's star, that is multiplication, it's first times s. If it's slash, that is division, it's first by s. And all these values are returned. Last, if none of these happen, it is automatically assumed that it's going to be a modulus operator. So we do the modulus function. So after each statement, after each case statement, we have a break. This break is not required. So that's it. So that's ends there, and this value coming here is passed here, and this value is in turn push the stack for further operation. So after this is done, then we have a plus. So again the same process will happen. So this value which we got from the first time is added with this 10, and then after that we have 3 that is being pushed to the stack. Then last we have minus. So this 3 and the value which we calculated from the first 2 operation is is operated. So that value minus 3. So after this is done, we get the result which we just print the top of the stack. After every operation, the result is stored in the stack. So it is assumed that at the end of all operations, the value the stack will only have one value, and the value is and that value can be accessed using the top function. So I just print this result, and I just give an end line. So here I'm going to show you the output of this function of this program. So his stack application. So here I'm going to give the same input. It should return 23. So let's see, 10, 2, 8 star plus 3 minus. So as you can see, the answer is 23. Let's verify this. So 8 times 2 will be 16. 16 plus 10 will be 26. Then 26 minus 3 is 23. The answer is right. Let's try once more. So here, say I'm giving some big number, 383, 1 times then a minus 3. So it's 380, as you can see. So this 383 times 1, then this value minus 3. So that's 3. So as you can see, the program works. And thank you.